Hello. So we are going to continue after a very long time, and we started off because we are looking at data. We're looking at how data is crashed. We're looking at some of the fundamentals for data analytics. That is mostly Python fundamentals for data analytics. We looked at why do we use Python, um, what are data variables. We looked at let me just show you here actually, so that you have a look at what I'm also looking at. Just downloading it. Yes, yeah. So I was just taking you through some of the things that we had a look at. Hello. So we're going to start where we left from. But again, just a quick preview of what we did sometimes back. So we started with the fundamentals, the fundamentals of data analytics. We discussed why Python, and we said that it's simple to read, it's easy to popular. We went to data types, Boolean, integer, strings, plots. We discussed about what lists are. So here we're just discussing about how data is stored. It's stored in lists, and all that. We also discussed about dictionaries. Then now, from looking at dictionaries, lists, and data types, we went to conditional logic. So this conditional logic is more about the if-else statements, as you can see here. If data is greater than equals to what would happen for that logical operators, comparison operators. Now, from there, I just want to take you through quickly for loops and what is called functions. Now, we've come from the data types. What are data types? We come to how data types are presented in loops, in dictionaries. Then we come to conditional logic. Now, for loops. Now, imagine you're having your data, right? Your data is in a list. Say this list is in the list is A. Your data type is 1, 2, 4, and let's say 8, right? That is your list. It has been assigned to this variable A. So the fact that it has been assigned to this variable A means that if I want to work with each and every element, so these are elements, then it means that I need to do A, and we say the first element here is you access it from the starts from zero. Let's say from zero, I want to add 10, and for all of them, I want for one I also want to add 10. For two, I want to add 10. So imagine how long you do this. It will take some time. Let's say you have like 100 elements in a list. It will take quite some time. So now comes the follow. So what does the follow do? The follow comes and looks at this list and tries to execute an element at a time in that list. So it's like you're looping through that list and able to apply some logic, able to apply some arithmetic condition there to add something, for example. And then for that, it really makes this efficient because you do not have to do this over and over again. So the algorithm is, for example, for then we take a temporary. You can use any value that you want to use. You can use say for x in. So you're talking about for x in. So it's more like an English, way of doing things. So you can say for x in A. So A is always the say for x in A. Then you put this colon here and say, I want to print every value. So what you're saying here is that for x represents a temporary value for each and every value here one at a time. So we say for x, it starts at index zero. So we say print x. So what it will do is it will go for x in a. So it starts as just say, oh, for one, I'll print x. Then it should loop again. For two, I'll print x. I mean, you've already assigned two to x. So you print two, you print four, you print eight. If you want to do something more sophisticated with this, right? You can even say, I want to print, let's say, a plus or a multiplied. You put two asterisks here. You say a squared, or I mean x squared, not a. So what do you do here? You take one for the first element, square it, then print. Then goes to the second, square it, print. Like that, like that, like that, until it finishes what is in the list. And you can even say, you can even put a null over here. You can try something else. Let's say for x here, I want to add 20. So what it will do is to print, right? It will take, it will come to the first one and say 1 plus 20. And even for each story, what is called readability, right? So that you're able to understand what your code does. And say, I want to be here. So B will be x. So you're introducing a new variable here. Say x plus 10. Then you print B for readability, for you to understand what the code is all about. So we say for x in A, B is equals to x plus 10, print B. So that will do it, you'll come here and take x, because you're looping through using this 4x in A. You're looping through and you should go to print that. So that is what is it when you're talking about loops. So talking about functions. So let's just talk about functions quickly. So for functions, we have what is called parameters. So functions really help us to, for example, we're talking here about functions. So for you to be able to work with functions, so functions are introduced by keyword def. So def, and you write, for example, is calculate total, right? At least you need to name your functions in a way that we understand. So df is just a keyword that is used to let you know that you're dealing with a function. And calculate total is not the function itself. So function act as a way of trying to containerize. Let's say containerize, trying to bring together, you know, operations that you do so that you're able to use that function everywhere else using what is called parameters. For example, here, parameter, you can say calculate price here, price, something of the sort. So inside here, you say now, for this function, for you to calculate total, you'll be able, and maybe here you have tax as you've seen there. So for you to be able to calculate total, so the tax amount here, the tax amount. So this is a variable that you're introducing inside the function. As you see here, it will be price times tax. Then the total will be the price plus the tax amount. Actually, this is how it works, right? So you take the tax amount is equals to price times price times tax. Then the total will be the price plus the tax amount. Then now you return the total. So what you realize here is in this function here, you've not indicated the price, right? You've just put a placeholder. These are what are called parameters. These are just placeholders. Then you run this function. So the reason why we're doing this is so that you can be able to put different tax amounts. So when you come to run this function, you will come and say calculate total, then put in half the price. Let's say 100, and then you put the tax amount, maybe just 2%. So what will happen here is now the function itself will take this because you'd already said tax amount is price. So if you put 100 here, the 100 will be you'll take the 100, then you multiply by the tax percent, right? Then the total will be the price. So the function itself will take these parameters and take them to trickle them down to the function, calculate, then return. Because you see here, from return total, that the total has already been defined inside the function. So the reason for this is you can just take this function again. You can take this calculate function, right? And give it other parameters, right? You can give it 200, 50, and then whatever 5%. So it means that now you can use this function in so many other. So let's see. So we are going to start the Python implementation of loops that go to functions. As you can see, here. Oh, you can see it. Yeah, but we need to start with the loops. So then we discuss what loops are and functions. So these two actually helps make the process of analysis very efficient, because at the end of the day, you don't have to repeat so many things. You just use, these loops, and you just use functions and can use them in different places, so that you, because if the logic is the same, then you just need to change maybe the parameters of the data, so that you get it. So yeah, sorry, you can be able to see that. So for loops, as we stated earlier, so this is a list. You can see there's a list of strings, and you can even print it. You're able to see these are list of strings. So what you want to do is you want to look through each element in the list and just print it with an FHL or a string before that, so that it is more descriptive. So when you do that, then it's get processing. Yeah. So what you've done is we go through each and every string in that element, and even before that, I'll put in pre-processing bits so that you're able to see. So what you've done is we go through unga rice and all that. So the same thing, you can do the same thing with another method that is used with for loops. It's called enumerate. Enumerate is you want to print also the indices, right? The indices of the elements in the list. So when we say that indices starts with the zero, and what you see here is I plus one. This one is you don't want to put in that zero. You want to put that one because you want to list them. So what you do is you put for I into product represents, each element. It's like a temporary variable for each element in enumerate. So enumerate, then you delete the packets products. So you do print, then you do the F literal, this is what you get. So when you do that, that is what you get. Then again, you can look over a range of numbers. So we can also use for loops with another method called range. Now for range, this is what you do. Range 1 to 13. So this is what you get here. But for range, it's x 1 to 13 means that 13 is exclusive, it's not excluded. It will include 1 to 12 because we have 12 months in a year, right? Yeah, so that is it. Then when you print, you can still use the F-literal, or you can just print as is. But for for it to be more descriptive, then you just do that. This is what you get. Yeah, you can also look over dictionary, right? But for dictionary, you need to put this special method called dot items. Dot items. So for quarter and revenue, because we have these are key value pairs. Remember dictionaries said key value pairs. So the key value pairs. So the quarter here and the revenue. This is for the keys and this is for the values. And in quarterly revenue dot items. So dot items is it tries to put this in a list so that you can be able to work with them. So if there's a growth, this is a variable that has been introduced here so that you're able to calculate the growth from the first quarter, because you're talking about from the first quarter to the last quarter. So how do you calculate growth from the first quarter to the last quarter? Of course, the first quarter will be 0%, but after that, it means that there should be growth, or maybe there is also a decline. Who knows? So you need to do that. Then you print the FBITROL and you define with the quarter, because you say for the quarter. For the first element in the dictionary, it will print quarter one because you had already differentiated quarter and revenue, the key value. So when you do that, this is what you see: quarter 1, 2, 3, 4, and you see now the growth 11, 2.4%. So that is how loops work. The same thing with functions. We talked about creating a function that you want to call anytime. Reason because you just put in a parameter that can be called. Yeah, so as I was talking about the functions, I'm not sure where I stopped, but yeah, so that is how you call the function. Now, we want to create a more robust function here. So the function here is, you define it, summarize data, right? And we have two parameters. Then you put the semicolon. And one thing is actually you need to be very keen about indentation in Python. Python doesn't use like commas or semicolons. It's very, very sensitive to indentation. So you need to be very, very keen now with the indentation here. So as you see here, when you define a function and put a colon here, you need to indent it, right? You need to indent it as you see here. So what you're doing is we are defining a function here. Now the function that we're defining here is what is called summarize data. And in this summarized data, we have two parameters, data and label data. So when you see data and label data inside that function called summarized data, those two things, right, those two parameters are the ones that are going to define the function itself. They're the ones that are going to build in what is inside the function. But of course, you're not using when you're defining the function, you're not using the exact, parameters, right? We're just putting in placeholders and parameters we said are like just placeholders. So here, we're saying that data and label data. So you come here and introduce now what I talked about here, variables. So we start with count. And we say now for count, what does count mean? It means that if you have data that is in a list, right, and you do len, that means that you're going to get the count of the number of elements in that list. The second is sum, main, master, all that. Then after you've gotten that, it doesn't mean that it will be printed. Now, you need to print all of them and you need to return the average, right? So that is how these things work. But now, when you run this, this that you defined, nothing will happen, right? Nothing will happen. Reason is you just defined the function. So what will happen next is now you need now to supply it because the function itself say that this function is called summarize data. So the reason it's called summarize data it means that now you need to supply the data, and if you do not have the label, it's okay. You just continue. You just call it. It will just be called data because this is the default label. But if you have a label that you want to know, you can do it. You see what is being done here. So generally, average is summarized data. Jump cell. Yeah. So this is the magic that you see here. After doing all this, right? So this is the magic that you see down here, and that's it.